I'm going to talk you through three key resources that we use for online work as we're prepping for field work or as we're working through this data. So the first is StreamStats. StreamStats is an incredibly useful tool. It's put out by the USGS. So I usually get to it just by Googling StreamStats, but the URL is up here. And you just click Access Application from here. So this is the simpler, straight to the application URL. There are usually some news and updates about the status of StreamStats at any given time, and then you get to the map of the US. So we're going to zoom in on the Athens area. So really you have to zoom in to be able to do very many things. You can see as we zoom in that these gray lines are delineating hydrologic units, and they get finer as we zoom in. So we'll zoom in right into Athens. These square or these triangles even represent different monitoring stations. So this one is a gauge station. So you can get to a stream gauge. We'll talk about stream gauges in a minute, but you can click right to that stream gauge page and look at the water level and some other data alongside that as well. So in order to actually do any analysis in here, we have to make sure that it shows that we're in Ohio. So we click Ohio. And then as we zoom in, we can then use a delineation tool. And this will allow us to delineate the watershed that's flowing to a point. So let's say we want to figure out how much land and characteristics of the land that are flowing to the gauge station that's just off of Stimson Avenue in Athens. So we're going to start by clicking the delineate button. And then we'll go over and we'll click on this river line, on this flow line on the map by the gauge station. It can take a few minutes, especially if the internet's a little bit slow. So it's going to delineate this watershed, and what it's going to do is it's going to zoom back out, and it's going to show us that all of the land area that drains to the point that I clicked there on the river. We'll then be able to build a report and find out other information about that site. All right, so what you can see here is all of this yellow highlighted area, so all the way up to Lancaster, drains to Athens. So, really it's a lot of river that drains to Athens. So we can then scroll down and look at water use data. We can download the basin to be able to use that in GIS, or we can click continue. And so I usually use this to get different statistics about that, about the watershed. So there are a lot of different statistics that you can get. These are all detailed in the USGS literature. And you can also get basin characteristics. So what I'll do is I'll select all of the basin characteristics that we can get. But essentially there's one about change in elevation, we get drainage area, the percent forest, the latitude of the middle of the basin and the longitude of the middle of the basin, the amount of developed land, the amount of impervious surface, the percent of water bodies and wetlands, the length of the longest flow path from very upstream to downstream, the longitude of the center. These region A and region C indicators are important for flow estimation that you'll do later in this class. And mean annual precipitation, and then a streamflow variability index, which is a difference between the top flows and the bottom flows, basically. So we've selected all of those. We'll say continue. So it's going to calculate all of those things for this yellow basin that we've highlighted. So we'll just look at a couple of those things, and then we'll move on to the next tool. Right, so we're going to click continue. And now we get a report. And so you can customize this report and download it and share it. But essentially you get the map of the basin, and then we get a calculation of each of those parameters that we were looking at. So the change of elevation along there is about 4 feet per mile. Athens the land that drains to Athens there is about 942 square miles, and over half of that's forested. We also have the latitude. There's almost 10% urban in that area, about a little less than 2% of impervious, which is actually pretty impressive. You know, it is indicative of higher water quality. About 1% of water bodies and wetlands. It's about 89 miles from upstream to there in Athens. That's our longitude. And then this says that we're in Region A, not in Region C. And our annual precipitation is 39.3 inches. And then this is our streamflow variability index. So again, you can look up the definition of all of these terms in the literature that's alongside stream stats. So this can be a really powerful tool. I have to say the most useful thing that we use it for is actually calculating the drainage area, because that can be really important for many things that we do. The National Water Information System. So this is essentially the whole network of stream gauges across the US. And so stream gauges will measure depth of the water, which is then correlated to flow. Some of them also measure water quality, but not all of them. So when we go into the landing page here, what you can see is they're, across the US, they're colored based on, what percentile flow those stations are reading right now. So you can see right now it's pretty dry in the Southwest, it's pretty dry in the Northeast, and it's wet in the middle. And so again, we're gonna go into Ohio. And this is the one that's right in the middle of Athens that we were looking at earlier. This is the Hocking River at Athens. And so what we get when we go into this home page is a discharge in cubic feet per second. This will be provisional data until the USGS has gone out several times during the year, so I think it's at least 7, to verify the relationship between stream flow and the depth of the water. But you can see the variation in the depth of water, or you can see the variation in the discharge here. And this is a calculated discharge, and again, this is provisional data right now. You can see it says that down here. And it's been raining today, so you can now see where that discharge is increasing. There's also some comparison to averages. So on this day, the maximum that we've seen recorded was in 1935. It was almost 6,000 cubic feet per second. Our median for this time of year is about almost 210, and we're at 183. So we're a little drier than the median, but we're within that middle percentile. What's actually measured is the gauge height. So this is the number of feet of water at that gauge station. And so then this is then related to the flow using an equation that's developed annually. So again, what you can see is we have pretty low flow conditions, and then it's been raining today, and so we now have this increase in depth, which is reflected in the other graph that also shows an increase in flow. So some of these stations do have other data. Some of them measure some water chemistry and things like that. A lot of that's based on local funding, so it really depends. You can also go up here and get time series of daily data, daily statistics. You can download all of this data. You can get a lot of different things, and what's actually available depends on the site. So in here, this box is where you would set up to download things. When I download them, in order to analyze that data, I usually use a tab separated or a table file. And you'll see here in this available period, how long that data is available for. And so at this site right now, they're showing available as 1993 to 2020. There is data at the site from earlier than that. I am not sure why it's not showing up right now. And then there's also places where you can get additional information about the site. So there's a summary of all available data page, for example. And this is where you can see, for example, for discharge, our earliest data is from 1915 at this site. And so we can get a pretty big range of data from these sites. And so this is a really great tool to explore as well. this is called Ohio Watershed Data. So Ohio Watershed Data is actually a site that we developed and built at the Voynier School at Ohio University, and it supports a lot of different things, but a big surface water data set, a smaller groundwater data set, a lot of different reports and tools, some information about some key acid mine drainage watersheds, contact information. There's a watershed education page that has some really interesting information on it. And so we're going to go into surface water, and we're going to go to the state of Ohio. So there are a lot of different groups and watersheds that use the site, and so we can just pull up the data for one of those things. So if you're only interested in Captina Creek, you can just pull up Captina Creek. We're going to go to the state of Ohio and just look at the breadth of data and how we can get into some of that. So we'll click on the state of Ohio. And so first what you'll see is all of the watersheds in the state of Ohio are colored based on how much data is in those watersheds. And so you can see that most of our data is in this coal-bearing region of Ohio, where we have a lot of coal mining data. So we're going to scroll, we're going to zoom in. So there's Athens again. We're going to zoom in into the headwaters of Raccoon Creek into a stream called Hewitt Fork. So Hewitt Fork is here. Hewitt Fork is used to be a major contributor of acid mine drainage to Raccoon Creek, but has improved a lot over the years. So we are going to go downstream some. I'm trying to get to the mouth of Hewitt Fork. Okay, to the mouth of Hewitt Fork. So HF010 is the site that's at the mouth of Hewitt Fork. So firstly, what you can see is for many of these, we now have a photo of the site. So that pops up. There's some information about where to park and some information about the site itself. If we click on that site, then information will load over here on this right-hand side. So the location of the site, a site description, our site ID, the mile markers, the drainage area, and some additional information about the location. We can also then click over to chem data, and we'll pull up, we'll be able to pull up all of the chem data that we have for this site. It's also all downloadable. And then biodata will also pull up all of the fish and macroinvertebrate data that we have for the site. And so for this site, it's a key monitoring site, and so it's a site that we have a lot of data at. And so we can do a couple of different things that are really interesting using this. So firstly, one of the things that we talk about are the river miles of a stream. And so we can, oh, not that one. We can go to show layers, and we can turn on the river mile map. I don't suggest you do this until you get zoomed in on your site, because it's kind of hard to find your site once you have this on. But when we look at trying to figure out what river mile we're at, we need to figure out the river mile of the confluence of our stream with the next stream down, so we can say how many river miles up that stream we are. And then we need to say how many river miles we are up the next one. So essentially, there's a set of maps from the 1970s that a set of Ohio EPA interns had to go out and mark in 0.1 mile increments through every water body in Ohio. So essentially what we can do is say, okay, our site is HF010. This is the main stem of Raccoon Creek. So here we can see 89 miles. I'll go downstream a little bit more and find there's 87 miles, here's 88 miles. So a lot of different numbers on these maps, so you kind of have to look around a little bit. But there's 89 miles, and then often when there's a confluence, they'll actually mark the mileage. So here you can see 89.54, and that makes sense because you got 89, 89.1, 89.2, 89.3, 89.4, 89.5, 89.54. So Hewitt Fork is at river mile 89.54 of Raccoon Creek. So that means it's 89.54 miles up Raccoon Creek from the confluence of Raccoon Creek on the Ohio River. So then if we wanted a river mileage for HF010, we would then follow these little tally marks, these little demarcations up Hewitt Fork. So here we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. There's 0.9 and 1. So this is at 0.85 miles up Hewitt Fork from Raccoon Creek. And so that's how we would then identify that. For a lot of the site numbers that we use, we will round and then use that site as our site ID. So HF was Hewitt Fork, and then 010 is because we're right near River Mile 1, whereas like HF 045 is at River Mile approximately 4.5. So we will sometimes use that to generalize them rather than using the full Ohio EPA river numbering system or site numbering system. However, you would use the same methodology to count up those river miles. So I'm going to turn that river mile map back off. So the next thing that we can do here, which is really interesting, is we can graph our data. So I'm going to click graph your data here. Because we're in the whole state of Ohio, this is a little bit tougher, but essentially we're going to go to Raccoon Creek here, and then we'll go to the headwaters of Raccoon Creek. Oh, there are 2 Raccoon Creeks in Ohio, though. I forgot that part. So I need to find the correct Raccoon Creek. There we go. Don't think it's that one. Oh, there we go. Okay, so Elk Fork, Raccoon Creek, and then Hewitt Fork, and then HF010. So I can change this to a line chart, a bar chart, or a scatter chart. I'm going to change it to a scatter chart. And now I can see all of the pH data for HF010 that we have since 1996. So I can really quickly look at any trends in pH. And so you can see a level of improvement over time there. You do the same thing for conductivity. Conductivity is pretty much all over the place. There's no really strong trend. But then if we look at something like net acidity, we went from being net acidic to reducing that acidity to a point where now we're net alkaline at that site. And so this is a pretty interesting way of viewing our data. What we can also do is we can download our data. So again, we're going to have to go in and find our watershed. So Raccoon Sims is the one that we're in here, Elk Fork, Raccoon Creek, Hewitt Fork. Sometimes this does take a little bit of knowledge of where you are, which can be a challenge if you're kind of new to a site. And then HF010. And then what I can do is I can either download all the biological data or all the chemical data for the full time period or for a specific date range for that site. And I can download it either as Excel or as an Access file. So that's a really, really helpful tool, particularly if you're trying to figure out some historical trends for an area. I also want to quickly show you a built-in tool here that we have called HydroView. So we'll click on HydroView. We're going to go to the Appalachian Basin HydroView into the web application link. There are users guides for HydroView and for watershed data that can be downloaded. So now we're in the Appalachian Basin HydroView. I'm going to agree and zoom into this. And essentially for the whole coolant-bearing region of Ohio, what we have here are all of these hydrologic units mapped and colored based on the key impairments that's noted by Ohio EPA. So if we go to our legend, what we can see is, these green counties are impacted by nutrients, whereas these orangey ones are impacted by sediment. This is the Wayne National Forest boundary. And then these blue dots are high quality wetlands. And so maybe we want to look at a place where there's impairment and there's high quality wetlands. And so now maybe we can implement something that's going to protect those high quality wetlands by reducing sedimentation or something like that. So it helps with project planning. These purple areas and yellow areas are a national water quality certification, and there are a lot of other data in here as well. So again, if we zoom in more, we'll pull up these red lines, and these red lines are, from aerial photos, are a delineation of places where there's insufficient riparian corridor. So this is a way of picking out sites that could potentially be reforested or improved to reduce sediment loading to the stream. And so again, you could look for a site like here where you've got 3 high quality wetlands, and maybe look upstream to see if there is some sort of source of the sedimentation that's causing this impairment, or that could be improved. So this same setup is built for both Appalachian, Ohio, and for the Dayton area. And so it's just a really nice clearinghouse for a lot of public data that can be all be overlaid in order to do some project development and zero in on areas that maybe need some water quality improvement. I encourage you to look through all these resources and make use of them because they can be really, really powerful.